Alright, we're looking at the review for topic 3. So we're going to start off by listing the transformations that occur to this original function. It's a quadratic function. It's listed a, h, and k, the three different parameters that could affect what happens to our graph. And so we'll break this down looking just at what happens when a is affected. Then we'll look at what happens when h is affected, and then we'll look at what happens when k is affected. So starting with a is the number that's in front of the x value, in front of the parentheses here. This is an example of a quadratic. So the parent function of a quadratic is centered at the origin, makes that parabola, that U shape. And we're simply saying how is it going to be affected with each of these parameter changes. So when that a value is affected, there's three different things that can happen. First of all, a could be less than 0. That would be a negative number. So if a is less than 0, if we have a negative, what's going to happen is that graph is going to reflect. So it's going to flip and point down. If it flips and point down, again, the word would be reflection or reflects across the x-axis. Okay? Now, a doesn't have to be negative. It could also just be a fractional amount, fraction of 1. So anything between 0 and 1. And if it's a fraction of a whole, then those y values on the function are going to become smaller. When you multiply by a half or a third, for example, the numbers become smaller, and it's going to make it look as if it's wider or flatter. So when those y values go down, the graph will eventually look wider, and the word we use for that is to compress. We say it's compressed. So when a is a fractional amount, we'll say it compresses by that factor, so by a factor of a, whatever a is. And then we can say that the opposite is true when a is greater than 1. When a is 2, 3, 4, 100, anything else greater than 1, multiplying those y values will then make the points higher, in effect look like it's stretched or narrower. And the word there, again in math, is stretch. So we say stretches by a factor of a. So those kind of act as multipliers. Multiplying by a fraction of a whole will compress, make it look wider, and multiplying by a number greater than 1, like 2 or 3, will then make that graph narrower and look stretched. Alright, so the other positions are not multipliers, they're adding and subtracting. It's just a matter of when is it being added or subtracted into what. So the h is adding and subtracting the x component. X on a graph moves left and right. And k is added after the x. It's with the y variable. So it's going to move along the y, which would be up and down. Now, if you'll notice in the original function, h is being subtracted already. So when you subtract a positive, it actually is negative. And when you subtract a negative, it's actually becoming positive. So long story short there, because of that sign, anything that happens to h is going to be the opposite of what you would expect to occur. So you would think right is positive, but right is actually going to be negative. And you'd think left would be negative, but left is actually positive. So when h is positive, we're actually going to move to the left h units. And when h is negative, we're going to move to the right h units. Just remember that with h, it's always going to do the opposite of what you would maybe have originally expected when you think plus, minus, and left and right on a graph. Now k, because it doesn't have that issue, it's already positive, it's going to do exactly what you would expect. So when k is positive, it will move up just like you would expect. And when it's negative, it will move down. Now, if you know this information, it will directly help you the whole way through here, specifically on number 2. So on number 2, you're now going to be taking example functions here based on the parent function, f of x equals the absolute value of x, and you're going to talk about the transformations that are occurring, which are these things right here. So knowing whether you're talking about a, h, or k, and then applying the correct transformation according to those. So we start off with a parent function f of x equals the absolute value of x. Remember, the absolute value of x is a v shape at the origin. And then we're simply going to talk about how that's transformed. Now, you're not actually going to be graphing this, just to give you kind of a visual of what we're going to be looking at here. So the first one, we have absolute value of x plus 2 minus 4. Now, because the plus 2 is inside the bars, it's going to act as the h position. And because the minus 4 is outside, it's going to act as the k position. A was unaffected. So this has an h and a k transformation. Now, h is plus 2. We know that plus actually goes the opposite because of h, so it's actually going to move to the left 2 units. And then k is minus 4. We know that's going to move it down. And again, this is exactly what we just went over on number 1, so you can use that information to help you here. It's going to correlate directly. So left 2 units, down 4 units. Now number 2, part B here, we've got a number out in front of the bar. That's going to be my a value, that's my multiplier. And then I've got a number inside again, which is again h. So that a value is greater than 1. So that's going to multiply it by 2. It's going to shift everything upward, which is going to make it narrower. The word we use is stretch, so we're going to say it's stretched by a factor of 2. But then that h is minus 3, which again is going to do the opposite of what we would think. So instead of saying it's going to move left, we're actually going to say it moves right 3 units. Okay, my next one, I've got again a number out in front, that's the a. There's nothing inside the bars, no h, but there is a value outside, that's that k position. So the a position here, we've got a fractional amount, a fraction of a whole. So that's going to multiply by half, which is in fact going to make it narrower, it's going to shrink it down. And the word we use is compressed, so it compresses by a factor of a half. And then that k value moving up 5 units. K moves things up and down. And then finally my last one here, I've got 4 things going on. I've got a negative, which directly affects the a position, the a parameter, but I've also got a 3. So there's 2 separate a parameter effects going on. There's also an h, that plus 1 inside the bars, and a k, the minus 6 outside. So 4 things going on, starting with the negative sign. When a graph is negative, it's going to reflect. Instead of pointing up, it will point down. So it's going to reflect across that x-axis. In other words, it's going to point down. But it's also going to stretch because multiplying by 3 is going to pull all those y values. So it can stretch pointing up, it can stretch pointing down. That part is not the same thing. So we're going to say it stretches by a factor of 3, even though it's pointing down. So it's going to be skinnier, it's just going to be skinnier pointed down. And then the h position is plus 1, that's actually going to go opposite of what we think, so it's going to go left 1 unit, and then k is down 6 units. So a lot going on that one that covered every possible position that you could have. And then finally, last thing on page 1, a little look at function notation, how it's going to relate to the table. So on number 3, we've got a table that shows values for f of x over here. So it doesn't have a table for g of x, but it does have a table of values for f of x. And we're going to use that information to fill in the blanks about this, about another function g of x. And it gives us the relationship between g of x, which doesn't have a table given to us, and f of x, which does. So it says that the values for g of x are equal to the values for f of x times 3. So in other words, if I know what the value is for f of x, I can multiply by 3, and I can get the same value for g of x. So if I want to know what g of 2 is, that's my question. What is g of 2? Well, that's my x value. And again, there's no table for me to just look that up, but I can substitute it in over here for f of x, and I can look that value up in the table. So g of 2 is the same thing as 3 times f of 2. And I have a table that tells me that f of 2 is 10. That means what is the y value when x is 2? So according to this chart for f of x, if x is 2, y is 10. So f of 2 is that value of 10. So that means that g of 2 is going to be 3 times 10, 3 times f of 2. And then that amount obviously is 30. So I know that g of 2 is 30 because I know that it's 3 times f of 2, which is 10. So using that same idea, I can continue to the next one. So here's a different example. We're going to use that same table as our as our illustration here. So I know that g of x is equal to f of x, this time just f of x minus 3. So I know that whatever value I'm looking for g of x, I can find the corresponding value in f of x, and I can simply just subtract 3. So if it's asking for g of 4, then to find g of 4, very simply, I can find f of 4, substituting for x there. So if I want to find g of 4, I can find f of 4 instead, but I have to subtract 3. So it's telling you what you have to do to find the value for g of x. So f of 4 on the table is 16, so I know that g of 4 is going to be that amount of 16, so 16 but minus 3. So that would put me at 13. Okay, continuing on, next one, same idea. G of x equals f of x plus 1. This time x plus 1 is in parentheses, so we need to be careful when we plug in here. It's asking for g of 3. So again, if I want to find g of 3, that's the same thing. That's equal to f of 3 plus 1. Now because that's in parentheses, I have to do that part first. So g of 3 is really equal to f of 4. 3 plus 1 is 4. So if I want to find g of 3, I can just find f of 4 because those are equal to each other. So since f of 4 on my table here is 16, I know that g of 3 has to be the same thing because they're equal to each other. So it must also be 16. And then finally, last one, I've got g of x is equal to negative f of x. So if I want to find g of 1, then I can really just find negative f of 1. So whatever f of 1 is, I can make it negative, that's g of 1. That's the relationship between the two according to what it says here. So f of 1, the function at 1 is 7. So then g of 1 has to be negative that amount, negative 7. So g of 1 is negative 7. Okay, and that's the end of page 1.